Welcome to day 5 of Advent of Code 2024. Today I solved part 1 in 4.5 minutes and part 2 in about 20 minutes. So part 2 was quite tricky, and I'll explain why in a bit. We're going to start with me solving the puzzles. I did it with a couple of friends. So here's a 20-minute screen recording of me solving the puzzles. And then afterwards, I'll explain how I solve them. All right, welcome to day 5 of Advent of Code 2024. We're going to lock in.
Yippee!
We're lopping so hard.
5, 4, 3.
Stop, that's stressing me out.
Sorry. Okay.
Alright. The fuck? Page ordering rules. Oh wait, what? I'm so confused. Are you like single-handedly doing this for the entire freaking dorm?
Oh, then half of the Megan ones.
Mm-hmm.
I'm not talking to you.
Are you done
Damn.
with both?
Wait, there's two?
Yeah.
Let me just think. Please, no one say
I was so
if you
confused. I
finish.
was like-
Guys, please. Are the updates always odd number lengths?
Yeah.
Okay.
Fuck, I can't beat this. It's a lot of printing.
This is all for you.
Oh, thanks, Queen. My bad. Oh, fuck. I'm stupid. Oh my god.
Fuck yeah, part 1, okay. Oops.
I'm gonna get demonetized.
Wait, no, it's fine. I'm just so happy that, like, my code actually worked.
Alright, congrats.
BAM!
Oh my
Good
god.
job.
Dude, I realized what to do, but I have to do it in Python.
Wait, shush,
Shut
please.
the fuck up.
I'm just trying to, like... This is, like, the first time I...
668.
Oh my god, I'm falling off.
Same.
Wait, I know what to do. That's the problem.
I think I need to be less smart.
Wait, Alex. Can you do me a favor?
What up?
Can you go to the front desk and ask them for another roll of papers? Because I think we're gonna run out.
The fuck? How is that possible? How much I printed, right?
Sophia Medina printed.
Is this the B1's attempt to take over the government?
Mm-hmm.
If you want to have not gonna be there anymore.
Y'all are just constantly at war, huh? Sure, I'll be honest.
It's definitely wrong.
Gee, who's Megan?
Megan?
Yeah. Megan or Rat?
She knows he's born inside out. Also, I did not.
Oh, you do or you don't need it?
Don't.
Oh, you don't.
Wait, I don't mean to, like, be annoying, but, like... Sorry, never mind.
Calvin wants people to shut up.
Yes. Thank you, Tina. Evie,
Are you locked in, bro?
I was. I
You were.
just can't focus, bro.
Until GG.
Dude, I know exactly what I need to do. That is the problem.
Yeah, you see me too.
Tina's gonna implement the world's craziest data structure.
It's actually not okay.
Wait, are you actually?
Wait, no, it's just top secret.
Is it though? Because it didn't work for me.
It should work.
Wait, y'all are gonna cry when you hear my solution.
I will cry. Please don't
Y'all
tell
are
me.
actually gonna cry when you hear my solution.
Fuck, I have 4 seconds left. This is gonna be wrong and it's gonna be...
4?
Wait, it's actually so funny.
Shut the fuck up.
I made the world's craziest function.
Why do you always do this in the library?
It's a good place to convene.
Because it's a good place for people to be fucking quiet.
Exactly.
That's the loudest fucking one.
I've been quiet the whole time.
Oh my god.
Oh, I understand. Wait, what?
I hate this fucking. I hate this. I hate this fucking.
You got it?
I actually kill myself.
You got it? Nice. Finish the top of sword. How hard is top of sword? I have no idea.
Wait, it's easy, but I don't know how to do it in Python.
Bill shot his eyes at me.
Wait, Alex, please. Like, it's very stressful to like be trying to lock in.
Sorry.
Oh yeah.
Okay. That was so bad. So for part 1, we have to print a bunch of pages for the Slay launch safety manual, but the prints have to happen in a very specific order, which are given by these rules. Every rule states that one page must be printed before another. So for example, this first rule says page 47 must be printed before page 53, and so on and so forth. And then we're given a bunch of updates, or basically pages, that we have to print, and we have to determine which updates or pages are correct, and then add up the middle number in each of those updates. How we do this is with Python. So the input parsing merits a bit of explanation here. The input is of the form rules and then updates. And they're separated by 2 new line characters. So that's the first thing we do. We split by 2 new lines, and then we grab the rules as well as the updates. For every rule, we have to turn it into some integers, or I guess we could use strings, but I like to think of the pages as integers. So we have a list containing all of the rules, which we build by going through all of the rule strings, splitting by this pipe character, which separates page 1 from page 2. And then we turn both of those into integers and then add them to the rules list. So at the end, rules is going to be a tuple, a list of tuples which have 2 integers each. For the updates, this is a pretty standard way of converting lists of integers. They're separated by commas, so for every line in the updates part, we split it by commas, and then we map everything to an int, and then turn it into a list. So now we have all the updates as lists of integers. To determine whether an update or list of pages is valid, we go through all of the pages, and then we determine where in the list that page is using this index dictionary. So for every number in the list, every page number in the list, we determine what its index is, and then we just check to see if all of the rules are followed. So for every pair of pages in the rules A and B, A has to come before B. So if this rule applies, i.e. if both pages appear in the updates, then we need to make sure that page A appears before page B. And if that's not the case, then we return false to indicate that this update is not valid. But if at the end no rules are violated, then we can return true, meaning all of the rules are satisfied, as well as the middle number. So at the end, we go through all of the updates. If an update is valid, then we add the middle number, and that's how we get our answer for part 1. For part 2, we're asked to order the incorrectly ordered updates. So if we're given a list of pages and there is some rule that is violated, i.e. we need A to come before B, but in this list B comes before A, then we need to swap them around, fix things that the list of pages is in order and satisfies all the rules. How I did this was with topological sort. Essentially, we identify which page has to be first, and then which page has to be second, and then third, and so on and so forth, by basically looking at the rules and seeing which ones have no dependencies. So a page has a dependency if it needs to come after some other page. We determine which pages have no dependencies by going through all the rules and counting the in degree of every page. So the in degree is determined by how many pages need to come before a given page. So we just go through all of the rules, add an in degree to the latter page, basically meaning that the first page has to come before it. Now, while there are pages that have no, in counting the in degree of every page. So the in degree is determined by how many pages need to come before any given page, and we use a dictionary here to count that. I could have, I think, just used a regular dictionary instead of a default dict, but that's okay. We go through all the rules, basically all the rules that apply, so we filter that out in this section, and the latter page needs to come after the previous page, so we add an in degree to the latter page saying, hey, we have a dependency. Now, we build out the actual ordering of the pages, the correct ordering, and how we do that is going through all of the page numbers that have not yet been seen, so that's this part, we're filtering out the pages that have already been added to the answer. If a page does not have any dependencies, meaning it doesn't have any pages that need to come before it, then we can just add it to the end of the list because all its dependencies are satisfied. Once we add a page to the actual answer, then all of the pages that it is a dependency for now have one less dependency, and that's this line. We reduce the in degree of every page that has our current page as a dependency by 1. Now at the end, the update list should be sorted, and we just determine the middle number, add all of those up, and that's the answer. Now there is a slightly more intuitive way to do this, which is based on the understanding of this problem as a sorting problem. So we're basically just given a bunch of custom comparators saying, hey, 97 is less than 13, 97 is less than 61, so on and so forth, and then we need to sort the list of pages correctly. We can use any sorting algorithm we like. I think bubble sort is quite intuitive to follow. Basically, we go through all pairs of pages in the list, so that's this loop over here. We're going through every index and then looking at the page at that index as well as the page after that index. If those are out of order, i.e. the other way around is in the rules, so like say we have AB, but BA is in the rules, then we need to swap these two pages, and that's this line over here. We keep swapping while there are things to swap, and that's tracked by this isSorted variable over here. While the thing is not sorted, we just keep swapping elements as they're out of order, and at the end, if everything is in order, then since the comparator is transitive, in theory, it should be transitive, otherwise we have an issue, then the list is entirely sorted. So that's the bubble sort algorithm. At the end, we have sorted all of our updates, and we just do the same thing as in the previous solution, but I think this would have been much quicker to write and debug. So that's it for day 5 of Advent of Code 2024. If you want to check out my code, I've included both the topological sort and the bubble sort algorithm in the GitHub, which you can find a link to in the description. And if you have any comments or questions, feel free to leave them down below. Thanks for watching, and I'll see you tomorrow for day 6.